Good morning, my dear students. So, as we're discussing regarding about data link control functions, so already we completed the remaining two functions of the data link control, that is line discipline and flow of control. This is the last topic in data link control function, that is error control. So, what is error control? Error control is nothing but how can we detect and correct the errors while we are transmitting the data from source to destination. So that means error control is nothing but it is a process of identifying and rectifying the errors in a transmission. That means whenever you are sending the data from source to destination, at that time the data may not be received from source to destination as it is. Some at the time in the middle the data may be lost or the data may be corrupted. So finding these lossing of data and correcting of the data is the process called error control. So there are two types of error control methods: error detection and error correction. So error detection is nothing but finding the error, and error correction is nothing but rectifying the error. So error correction can be done through the following methods: CRC, VRC, LRC, checksum and parity bit techniques. That means in error detection what they can do means, from sender to destination, whenever they are sending the data, at the time they can add bit an extra bit can be added and send it to the destination. Whenever the at the time of receiving, the destination will check as it is data is received or not. For example, I am sending the data 1101, and at the time they can add one extra bit called as a parity bit, like 1. That means at the receiver side the destination must be received 11011 only, but the receiver may receive any of the data instead of 11001. That means automatically it will check, yes, there may be existing of a loss of data, or there may be existing of a the corrupted data. So to finding these, they use these methods like CRC, LRC, VRC, checksum and parity bit techniques are used for detecting the errors. The most very important thing is, whenever the receiver is receiving the data, at that time we need to rectifying the error. That means there may be chance of three types of error: single bit error, multiple bit error or burst error. So whenever that is identified by the error detection, but after getting that error we need to correct the error. So that can be done by error correction. That means error correction is a process by retransmitting the erroneous data frames from source to destination. So how many bits you are lost, or how many bits you need to correct, that bits to be retransmitted from source to destination, that process is called error correction. And here for that error correction we having different type of methods. So before we are discussing the techniques in the error correction, first of all we are to know what is ARQ techniques. ARQ stands for automatic repeat request, is one method where you can retransmit the erroneous data frames from sender to receiver. That is nothing but whatever the corrupted frames that is received by the receiver can be retransmitted by the sender. So these are the following two ARQ techniques that are used for error correction, that is stop and wait ARQ, sliding window ARQ. So already we discussed what is stop and wait control and sliding window control. So adding for that technique, automatic repeat request is called as an error correction. So stop and wait ARQ and sliding window ARQ. Again sliding window ARQ comes under two different, that is go back n frames and selective or repeat or reject ARQ. First we'll discuss what is stop and wait ARQ. So these are the following 4 points that you need to remember while we're discussing regarding about stop and wait ARQ. So the first point is, in stop and wait ARQ, it is used in the stop and wait flow of control. So whatever the flow of control we discussed in the stop and wait, the same implementation can be done in stop and wait ARQ, but the only difference is only one frame can send to the sender and wait for a positive acknowledgement before processing another and continue up to end of the transmission. That means, for example, I need to send the 4 frames, F1, F2, F3, F4 frames I need to send. Then whenever sender is sending the frame 1, and receiver must be give a response in the given period of time with the positive acknowledgement. If you get any negative acknowledgement from the receiver side due to some error in the frame data, the sender will again retransmit the lost data frame. That means, for example, frame 1 I am sending from sender to receiver. So we got the acknowledgement of frame 1. Again we are sending frame 2. Again we got the acknowledgement of frame 2. Again we are sending the frame 3. But there is a error. That means loss of the data frame or corrupted of the data frame. Then they are sending what? A negative acknowledgement. Whenever the negative acknowledgement is received from receiver to sender, then automatically it will send the whatever the lost frame again retransmitted. So this is called as a stop and wait ARQ until and unless you will get the acknowledgement. If you are getting positive acknowledgement, you can continue up to the end of the transmission. But if you get the negative acknowledgement from the receiver, then you need to send only the last frame from sender to receiver. That means here in this process the sender will maintain a timer. That means there may be a negative acknowledgement or there may be a time out. Within the given period of time, it may not receive any acknowledgement, that is treated as a data lost or lost of the frame. And the next topic is regarding about sliding window ARQ. In sliding window ARQ, we having two methods: go back and frame and selective repeat or selective reject ARQ. So as we already discussed regarding about sliding window, and sliding window consisting of a window size, and in window size we are representing the data frames. Data frame size must be less than the size. That means, for example, we are sending the window size is 5, then you can arrange the data into up to from 0 to 4, and here you are sending the data. So 0, 1, 2, 3, 4 are the frames that I want to send from sender to receiver. So before we are discussing the explanation about go back and queue, what is go back and queue ARQ? The sender start the retransmission with loss to an acknowledgement frame even the subsequent frames have arrived correctly at the receiver. And that means, for example, I need to send the frame size 3. I need to send the data frame size 3. That means at a time I can send more than one data frame. So 0, 1, 2 I am going to send from sender to receiver, frame 0, frame 1 and frame 2. At that time it will after receiving the receiver the complete window, it will give an acknowledgement like acknowledgement 0, acknowledgement 1 and acknowledgement 2, acknowledgement 2 like. But you can see frame 0, frame 1 you are getting the positive acknowledgement, but whenever the frame 2 is received, so there may be there existing of a error. So due to that error it is sending a negative acknowledgement, even though there is a correctly arrived the remaining frame also 3 and 4. Frame 3, frame 4 is also arrived correctly, even it is getting the acknowledgement of frame 3, frame 4. But before it is getting the acknowledgement frame 3 and frame 4, you are getting a negative acknowledgement due to error in frame 2. Then again what it will do means, whenever you are getting a negative acknowledgement for the frame 2, then after sending the frame 2, whatever the remaining data frame that you are sending, again it should be retransmitted. That means you can see retransmit frame 2, 3 from, that means frame 2 got error, then after that you are sending frame 3, frame 4. Again you need to send frame 2, frame 3, frame 4 until you will get a positive acknowledgement. The retransmission process can be exist within the given period of time. Why? Because sender will maintain a timer. So after that F2, F3, F4 we are sending. So again we are getting F2 acknowledgement, F3 acknowledgement and F4 acknowledgement. So this process can be exist when a damaged data frame. So whenever a damaged data frame is existing, that is frame 2 having damage, so due to that we are getting a negative acknowledgement. Another method in go back NQ is lost of acknowledgement. That means you are sending the data correctly, and whatever the data frame you are sending, there is no any damage in the data frame, but within the given period of time you may not receive any acknowledgement. That comes to lost of acknowledgement. So at that time what happens? See, in the given diagram, sender is sending the same frame 0, frame 1, frame 2. Whenever you are getting the acknowledgement. So you are still within the given period of time, you are not received of any acknowledgement regarding about these three acknowledgement, that comes to lost of acknowledgement. Then again what happen, it will retransmit, completely from f0, f1, f2, f3, f4. So here it is repeated f0, f1 and f2 once again. So that's why it is called an a go back n, that is number of automatic repeat request. So receiver is requesting automatically, you need to repeat the whatever the frame that you are sended previously, f0, f1, f2, due to loss of acknowledgement. So these are the two methods that are used in go back n rq. Here n stands for number of data frames. And now we can discuss the another method in the sliding window ARQ, that is selective repeat or selective reject automatic repeat request. So in that it is very important to remember these 2 points, that is here the receiver keeps a track of sequence number comma buffers the frames and sends only a negative acknowledgement frame which is missing or damaged. That means here the receiver, whenever it is going to receive any data, receiver should be maintain a sequence number of the data frame and buffers, that means how many frames ready to transmit, and it will send only a negative acknowledgement whenever the data frame is missing or it is damaged. So you can see the second point, sender sends only the frame which is received by the negative acknowledgement. That means whenever receiver is maintaining this all track of sequence number, buffer of the frame and the negative acknowledgement data, so whenever the sender is receiving any negative acknowledgement, only that particular negative acknowledgement frame should be retransmitted. So that is the concept of selective repeat or selective reject automatic request. Now you can see here the window size is 0, 1, 2, 3, 4. The same window I am taking and I am sending frame 0, frame 1, frame 2, frame 3, frame 4. You can see I am sending continuously frame 0, frame 1, frame 2, frame 3, frame 4 continuously I am sending, and the receiver is keep track of receiving the sequence number of the frame 0, frame 1, frame 2. So according to that it is sending the acknowledgement. See, acknowledgement 1 regarding about frame 1, acknowledgement 2 regarding about frame 2, acknowledgement 3, but you are not received the acknowledgement 3 from frame 3. That means they are sending negative acknowledgement of the frame 3. Then automatically what happen, the sender will find out the track of negative acknowledgement 3, that means it is related to frame 3, then select the frame 3 from the sender window, again that particular frame 3 can be sended and you will get the acknowledgement of the that particular sended frame 3. That means only the selected frame can be repeated, only the selected frames are repeated, not the complete frames which is already received. Even you are receiving that, you are sending the, again you are repeating 3 frames in the go back n cube, but here only the selected frames can be repeated. And these are the following points that should be remembered in the selective repeat or selective reject automatic repeat request. The first point is receiver must have sorting logic to record frames out of received. Why? Because why it is need sorting logic? Why? Because whenever receiver is receiving the frames like frame 0, frame 1, frame 2, frame 3, frame 4 and frame 5, in that we are losing the acknowledgement for frame 3. That means it must be having the sorting logic, it must sort. Yes, first one is 0, second, third and fourth one is missing and the fifth one is arrived. So that comes to sorting logic. And sender is having the searching mechanism. Why sender need a searching logic or a searching mechanism? Why? Because sender is having so many data frames, from that you need to search. Yes, 0 is sended, 1 is sended or not, or 2 is sended or not, or 3 is sended or not, like we need to go for search. Yes, 0 is sended and you got acknowledgement, 1 is sended, you got acknowledgement, 2 you are sended, you got an acknowledgement, but when you are sending 3 you are not got any acknowledgement. That means they will select the frame 3 for retransmitting from sender to receiver. And next, acknowledgement and negative acknowledgement, that means positive acknowledgement and negative acknowledgement frames use a sequence number. That means whether it is positive or negative, it must use a sequence number. You can see here acknowledgement 0, acknowledgement 1, acknowledgement 2, but you are getting here, see, negative acknowledgement for which one? The negative acknowledgement for the frame 3. So that comes to the sequence numbers. And smaller window size is used to reduce the complexity. That means, for example, you need to send a large number of data, then divide the large number of data into smaller window size, which will reduce the complexity in sender and receiver. That means more data, more complexity will be exist, and buffer will keep track of all the received frames. So as we discussed in the first point, whenever the receiver is receiving the any data frame, it will keep track of sequence number and buffer the frame. That means whenever it is received frame 0, frame 1, frame 2, then what is the window size? 5. That means now the buffer size will be decreased to 2. Why? Because only 2 more data should be received by the receiver. So this is regarding about selective, repeat and rejective ARQ.